Hello everyone. In this video, we'll see some examples of prototypal inheritance that are already implemented in JavaScript in native code, and we'll also see some ways that we can change or set prototypes to different objects or the objects that we want them to point to, and we will see how it can be done in some ways. So let's just open up console and let's say we create an empty object and try to see what an empty object holds. If I print this object, then it should have no properties, but it has a prototype. And what is the prototype? We can expand it here, or a different way to access a prototype is a dot underscore underscore proto. So it's kind of legacy to get and set prototypes, but it is not much recommended as it's obsolete now. So, but here we'll use it for our ease. So it's a pretty handy way to access prototype, but it's not recommended to use this way. We'll see other ways of setting and getting prototypes. We'll check how they work. So an empty object that we created has a prototype of object. And these are some things that we can do on any object, since any object will that is created will have object by default as a prototype, and object has a prototype of null. So because somewhere the chain has to end. And let's see, if we create an array, do we have the same prototype there or is it different? So let's create an array B. Let's give it some values. Let's try to print B. What it should have? It should have all its values and an additional property that is length. So, and it doesn't have any of the functions that we see with array. So array has a lot of functions, say pop. Array has a function pop, using which we can remove last element from the array. But we don't see it here. Where is it? It is there in the prototype of the array. If we go and open the prototype, see, it is implemented right here. Now, it is the same thing that we discussed in the previous lecture, that will have a constructor function which will create the object for us. So we had previously we saw that we were creating an object Nemo that was a shark, and it should have values age, weight, and kills, right? Age, weight, and kills, but it won't have any of the functionalities implemented, and will store all the functionalities in the prototype object, and functionalities will be directly shared via the prototypal chain. And it is something similar that we see here. We have our implementation of array B, and in B we only store properties that are length and other indices, but we do not hold we do not hold the functions that B can do. So B can push, pop, and do all those sort of things. We do not have them. We only have the values that are concerned to B. And we also have a constructor function that we actually utilize to create our array. So what this constructor function does. So implementation details won't be here, but we'll see what constructor function can do and how we can create our own constructor functions in later videos. So we just saw that B has B has a prototype. Now let's create one more array. Now C has also the same prototype that B has. So are they essentially same, or are there two copies of this prototype? We want to understand that. So what I'm saying is there is a prototype of array within C, and there was also a prototype of array within B, right here. Are these two prototypes same or different? So say this is array.prototype and B is pointing to B is pointing to this. Is is also pointing to this, or C has some other array.prototype which is a similar copy? What would be the case? Let's try to check it. And how can we check it? We can check it via trying to change some things within the prototype itself. We'll change something in prototype of B. We can access b.prototype using __ proto. And this is the prototype of B. So as we all know that there is something called map. B has a function called map. And what does map do? Map creates new arrays from the existing one, just like that. But what if we go and change this function map and change it to something entirely different, and say we offer a new implementation of map that says I won't do anything. So now if we try to call b.map, it won't do anything. But will it be changed for C as well? So let's call it for c.map. Oh, it is changed for C as well. So that concludes that object C that is there, also points to the same prototype object. And this is what we discussed previously. Now, and we also saw a very interesting thing, that we just changed the implementation of map. It is shipped by JavaScript, and we should never do that. We should never change the implementation of map. But if we can do this, if we can change the existing implementation of map, can we add new values here? Let's see if we can. Let me just erase this. Let's try to create a new function, remove, that will imitate what pop does, and we'll add it to the prototype object again. So we'll add new function remove to array.proto, and what this will do is this will have, let's have a variable temp here. Temp is equals to temp. So let's not implement pop completely. It would be 4 or 5 lines of code. Let's just do a simpler thing. Let's in GTH minus minus. Let's just have a partial implementation of pop. It won't work every time. We are missing some edge cases. But it what it will do is if there are any elements in array, it will remove the last element, and if there are zero elements, it will give error. So we just added a new feature to array.prototype, and by definition, the new feature should be shipped to every array that exists. So we added a new feature, remove in array.prototype here. Let's try to use it. B has three elements right now, and if we call b.remo, b.remove, okay, b.remove is a function, so we have to call it. So now B only has two elements, so it works fine. And will it work for C as well? C has five elements, and if I call array.remove, and if we print C now, and it removed the last element. So yes, we can. This is one way we can ship new features to JavaScript. So we just saw that how prototypical inheritance is working, and how we can change things in prototype, and in a flick of seconds that change is reflecting in all the objects that follow. And even if I create any new object, say I created a new array D that has some values, and I call d.map. So we have changed the implementation of map, due to which it's not working the way it should. So we have the power to change the prototypes that JavaScript already ships, and we just saw that we can do that, but it is not the best thing to do in the world. And how we can, like, someone can think that, oh, if I can ship new features to JavaScript itself, then it would be very helpful. Say somewhere in my product I need a feature where I have to jumble up array and do something like that, and this is not shipped by JavaScript. So let me do one thing. Let me create this feature and add it to array.prototype manually by my own hands, and use it in the places I need. It can be very tempting to do that, but that is an NT pattern. So it, I did it for purpose of explanation and showing you that how it can be done, or it can be done, but we shouldn't do it. We shouldn't modify, change, or remove, or add anything to the already existing prototype that are shipped with JavaScript. Why? Because of two reasons. It will be very confusing for the other developers which work with you to remember and adapt to the new features you have shipped to JavaScript. Because if someone comes to our code base and this is what map function is doing, they won't be happy. They really won't be much happy about it, and they'll definitely break something somewhere due to this. And if someone will come and see how remove is working in our code base, they will be a lot confused that is there a remove function on array? This is not expected behavior. Other big drawback is, say today there is no function named as remove in JavaScript on arrays, but say 5 years from now someone plans to ship a feature called remove. That will break your code, because because the developers that will be working on your code at that point of time will have a new idea of remove, and this remove will be working in an entirely different way. It might break things some at some place, even if you implement it very efficiently. What other problems it can create hypothetically, if the feature that you have shipped is very useful and everyone around the world is somehow using it, it got very popular, then in future it will hinder everyone in the community to ship new features to JavaScript itself. Because say you shipped something called remove, and tomorrow people developing JavaScript want to add a feature named remove, and they want to add it with slight different implementation detail. So they would be blocked because they won't want to break the implementation of a very popular library that you created, adding this remove to array dot prototype. They won't be willing to break it, but they would be blocked to ship a new feature to native JavaScript. So in this way, you can also pollute the JavaScript environment entirely. So these are some reasons due to which you should not modify, delete, or create new things within the pre-shipped uh, prototypes that we have for arrays, maps, and all sort of things. And we also saw what are prototypes. So similarly, we'll have prototypes for other things as well. So if we create, let's say we create X as a map. So X will have size and entries, and similar to that, it will have a prototype. A prototype will have the constructor function for map. It will also have other functions that map has: clear, delete, for each, get, has, keys, and all sort of things. And this is how most of the native things are implemented in JavaScript. So these were some examples of prototypal inheritance that exist in the native JavaScript. And in some next set of videos, we'll also see how we can set up the same things and how we can uh, create prototypical inheritance models using constructor functions and prototype objects, and how we can do all these things. Now, as part of this video, let's also look at some common ways to set prototype objects to a different object. So let's say, let's refresh this window. And let's say I have an object, and let's recreate this scenario that we had previously here. So here what we had as a scenario is that we had prod as the prototype object and X as a different object that points to prototype for that points to prod as prototype, and we were trying to access X.name. Let's try to do this. We'll do it in a couple of different ways. So let's have two objects. Let's have prod, and it will have, let's say it has a value name that is table, and let's have X, and X will have some size. Let's keep it short, and let's set. Now what we want to do, we have two objects. we have an object prod. So I'm intentionally emphasizing on these concepts so that they settle up in everyone's mind. And we want to set this relationship between x and prod, which relationship that prototype of x points to prod object. Okay, I'm intentionally reiterating these things now so that this concept of prototype sets up very clearly in our minds. So one of the ways to set prototype is x dot proto. We are proto, and what we want x dot proto to be is prod. Okay. Now if you print x, and what x has size only, but the prototype of x is prod object. Okay. Now let's try to access x dot size. It is 4. Let's try to access x dot prod. Okay. X dot name. It is table. Although we don't have this value name within x, but where it is coming from? It is coming from our prototype that we just set to prod. So this is one of the ways we can set prototype by directly typing x dot underscore underscore proto and equating it with the value we want to set it to. But this underscore underscore proto is uh, an older way of doing it, and it's not recommended to use it now. There are better ways and newer ways to do it, and it's kind of obsolete. It's not going anywhere near future, but it's advised to not to use it. So what are other ways to use it? So say we have one more product called y. It has size 5, and now we want to set it to have prod as its prototype. So how I'll do that? There is a function called on objects. There is a function called object.set prototype of, and of which object we want to set prototype. We want to set prototype of y, and what we want to set prototype as prod. So here we set it, and now if we check value of y is object 5, and prototype of y is set it to prod. And similar way as we could access y dot name, we can access x dot name, we can access y dot name as well. But now this is a better way to set prototypes as compared to x dot proto. But we need to keep in mind that setting up prototype is an hefty process, and it's also not so it's the if we need to set up a prototype, then it is the way we should set prototype of an object dynamically. But this is also not the best way of setting up a prototype. Now why is that? I I teach you a way and I will say this is not the way. Then what is the best way? Why is that? Because why it is not the best way? When we set this prototype here, when we created this value y, we already have something set it to the prototype of y. And now when we are again setting the prototype of y here, what we are doing, we are erasing what was written there, and we are again writing something else here. So there is a lot of work that we have to do. But what if when we create this object y, at that point only we specify, oh, you're going to create this new object. Do one thing, set the prototype as this object. What if we do that? Won't it be better? Yes. So how to do that? For that, we can leverage a different syntax, that is object dot create, and we can pass the the base object that we should use as prototype. So this way z is created, and z has, let's see what z has the prototype of this prod. Okay, and now we can set values in z, that z dot size, say it has a size of 6. Now if we print z dot name, it will also print name, and this prod object is again shared between these three objects. This prod object that has value of name, that is right now table, is shared between x, and y is also pointing it for its prototype, and z is also pointing it for its prototype, and it is shared. So what if we change the value from z dot name to something else? Say we change it to a car. Let's try to do that. And we say z dot name is car. So when we do that, we change it for everyone, because this prototype is shared between all, right? So now if we try to access y dot name, okay, it is stable only. Why did that happen? Because when we access dot name, actually we created a new property. Oh, yeah, that will happen because that's how it's meant to be. And let's just delete it for now. I made a little mistake over there. Delete. We can delete properties within z.y, right? If I remember correctly. Now we deleted z.y was nothing. Z.name we wanted to delete. So we deleted this name thing from z. So we'll see this in a different way. So if we change the property of underscore underscore proto dot name, now we specifically specified it that we don't want to add a new property to z, but we want to change the existing one that's coming from the prototype. Now we set it to car. Now if we call z dot name, then it's car, and if we call pardon y dot name, then it's also car, and if we call x dot name, then it's also car, because this is shared between all of them. Now what we'll do is we'll add something to prod. We'll add a new function, say get size, and what get size does is function Okay, prod dot get size. It will be a function, and what it is, it will return this dot size. So now we added a new uh, value to prod, and it is again accessible from everyone. So let's try to call get.size from z. It prints 6 for z. Let's try to access for y. It prints 5, and for x it will print 4. Why it's printing different values for all of these? Because this function is shared. This function get size is shared, but we we have our own values of size. So it has a value of 6, y has a value of 5, and x has a value of size, that is 4. So this is why this is this is why we get different values, because what we do is we access this dot size. Now what this refers to? This refers to the object that calls this function. Now when I call this function from z, then this refers to z, and z has the value 6 in it. When I call this function from y, then this refers to y, and y has a value of 5. When I call it from from x, it has a value of, this points to x, and it has value of 4. Suppose I call it from prod, because it's inside prod, right? We can also call it from prod. What it should give? It should give undefined, because prod has no value there, right? So it gave undefined. So this is how we can utilize prototypal inheritance. And this, what I showed you right now, is the manual way of setting up things. It is not the ideal way that we do, but this is one way we can do. Ideal way is either using class syntax or using constructor function syntax. And in coming up videos, we'll try to understand how we can utilize both of them and how we can use them. Okay, so that must be it for this video. Let's jump into the next one.